This is the fourth exercise of mold design, mold set principles. And in this exercise, we will follow the mix and match method, which means that we will build the different mold sub-assembly separately. Okay, and after that, first what we need to do is open the catalog locations. So for example, my catalog location is under C, and this is my catalog locations, and yours may be different from my one. So I open my catalog locations, and you can see that the have different types of the catalog here, and we have the Misumi, LKM, and all that. Yeah, so and here we create a new folder. So we name it as mold sets. So what I call that, and this folder will hold all your mold sets. Yeah, and inside this folder we will open subfolder for each mold set sub assembly we will create. Okay, so now we close it. Okay, next we will build the setup tables, and this setup tables is meant to be used for all of our molds, and you must consider all your mold set needs and build a comprehensive setup tables that will suit all your needs. And if you have very different types of molds, and of course you may build several types of setup tables, and if you do that, it is best to separate each type to a different folder. So now what we need to do is open the new assembly. So this is our new assembly, and okay. And this is the PMI guide. I want to hide it, and we go to view pens guides and select this mold design guide, and or you can go to mold design, select the setup, and this we select the mold design options. Okay, so this is the table, and now we check this enable advanced editing options and click OK. So when you are check this enable advanced editing options, and it will allow you to create new values and fully edit the setup tables. So we start editing, adding the values to the tables. So just double click the new items here, double click. So I will do key in one by one. Fix site. This is fixed site, okay, and then another one is F space. Later I will explain to you what does F space means and all that. And the value also same, just double click the new items here, also same. This is 400. Okay, this also 15, and this is FC PH. This is 18. Okay, now it's the movable side. M space. Okay, this value is 5, and this one is MP1H 300, MP2H 40, MP3H, and this is 45. This is rows H150, and then this CPH, and this value is 32. Okay, and then H rows width is about 300. Length is about 600. Okay, this is the V. Rows width is 150. Okay, now is ejections. So this is P1H is about 22. Is 0, and this we go to the global. Okay, this length is 1850. The width is 1000, and lead pin diameter is about 60, and the height is 150. Pin this is 74. And the last one is the delta is 180. Okay, so this is the set. Yeah, so just now I just key in all this and not yet explain to you what this means. The F space, the F1 pH, and all that. So the F space is an option for a space between the parting plane and the first plane, and the symbol F is for fixed side. The plate is plate 1. P is for plate 1. P1 is plate 1. H is for the height. And this means this is the height of the first plate on the fixed side. So F is for fixed side, C for clamping plate, CP is for clamping plate, and the H is for the height. and this means the height of the templing plate on the fixed side. Okay, this H rail width, it means the width of horizontal rails. Okay, the V rails width is the width of vertical rails. The M length is the length of the mold, and the width is the mold width. And the lead pin diameters is the diameter of the leading pins, and the H is horizontal of the leading pins, and the CP delta is different size between the mold plates and the clamping plates. The size different between both of them. Okay, after that we click this save as to save these setup tables. So save it into the mold set folder just now we create. So I name it as type A, for example, yeah. In step 3, we will building the mold sub-assembly. It is fixed site. So first thing what we need to do is close the assembly. This one, just now we create. No. Okay, after that we open the folder. So remember, the folder is under small set folder. Under the catalog locations, and this the mold set folder, and at here we make a new folder and name it as fix site 2 plates. Okay, after that we create a new assembly and we save it, and the name of assembly is this fix site 2 plates. Okay, save it into the mold set folder. Mold set big site folder. Okay, and then we go to mold set or mold design, select the setup or select from here, and we select the mold design options. Okay, after that click this enable advanced editing options. Okay, and now after we check this will allow you to load the existing template. Just now we create that one, the template. So this we load template, load from the catalog mold set. This is our template. Open. So this we load already the template just now we create, and then click OK. After we load the setup under the fixed site assembly, now we use add new component. Write a new part. Okay, and save it under the mold set fixed site 2 plates folder, and the name is fixed setup. Click setup and then click save. And this we change to on assembly UCS options. And then OK. Now we create a sketcher, middle mouse button to select the XY plane, and then we draw a rectangle. Okay, from the free option here we can change it to dimensions, and the width is 100. Okay, so I put it on the origin of the sketcher, and then right click exit sketcher. So at the sketcher here I just click or right click, select rename feature, and I name it as LP dash 1 dash L dash W. Okay, this means it's fixed side plate 1 length and width. Okay, next we just double click here the sketch to edit the dimensions. So do you see this, the 50 and 100? So we edit the 50, click here, okay, and then we open this show setup dimensions button. So this opens a dialog that will allow us to select the dimensions from the setup tables and use them in the dimension relations. So for now I select this M width, double click, and then here OK. So repeat this for the 100. This is the M length. OK. Middle mouse button to exit from the edit. Now we create another sketch. Middle mouse button. Okay, after that we draw a rectangle, change to free options. Okay, and then we add reference at here, middle mouse button, and then we add constraints, select the middle point and the origin of the UCS, and we select this same X. Okay, repeat for the other side for the same Y, select this for same Y, middle mouse button to exit. Okay, and then we give dimensions. One here to here is about 180. Also. Okay, after that middle mouse button. Right click exit sketcher. And then the name is fixed clamping plate, length and also the width. Okay, and we repeat this like the sketch. So we just double click and select this, set up dimensions. So this is equal to this clamping plate delta. Okay, and this also same. Middle mouse, sorry. Okay. So if you have the symbol F at the behind, this is step 4. Okay, next we will create the sketch for the screw. So we right click middle mouse button to select the XY plane, and then we draw a line like this. Okay, and after that we add constraints. Select the middle point and the origin point, same Y. Okay, and here to here is same X. Okay, and after that we add reference, middle mouse button, and then symmetry. Okay, the radius is 12 from free to dimension, and the radius is 12. Click add here, and then we create a circle at here. Okay, after that we give dimensions. Okay, this is about 100, and from here it is about 150. Okay, and after that we select this line, change construction line. Okay, after that right click exit sketcher. So this is the screw, and we don't forget to rename it. We name it as M24 screws. Okay, after we create the screw, the positions for the screw, now we create a sketch for the position of leading pins. So we select the sketcher, middle mouse button, and we add reference at here. Okay, after that you draw a box like this. Okay, and then we add constraints. Stand Y. Okay, after that we select all four of the edge, change construction lines. Okay, and after that we select the circle, and the diameter is 60. We select here. Okay, after that middle mouse button, and then we need to give dimensions. From here to here is 74, and the distance here is about 150. Right click, exit sketcher. Okay, and then we rename this as leading pin. Okay, and after that we just double click, and we need to connect the diameters and other dimensions. So same, and we select the leading pin diameter. Okay, and this also same. This 150 is the H. Okay, and this also same 74 degree. Okay, with the mouse button. Okay, next we will create the parallel plane, and so the XY plane was hidden at the archive here. So we just show the archive, and after that we go to datums plane parallel, and we select this plane. Make sure the arrow is pointing upwards, is Z positive, and the delta is 1. Right click, select OK, and then we off the archive. Okay, and after that we go back to the picture, and this we rename it as F space. Okay, and this is represent the space between the parting line level and the level of the first plate, and allow us to move the plate easily. So we create another parallel plane, and go to plane parallel and select this, pointing upward, and this time the delta is 400. Okay, right click, select OK, and we rename it as FP1H. So it represent the height of the plate 1 in the fixed side. And we repeat this process twice more times for delta 15. And the plane name is FP2H and 3H. So this is H, and this is FP3H. Okay, and then we create one more, and this is the delta is 80. And this we name it as FCPH. Okay, after that we connect the dimensions that has same name. This is FCPH. So we select this one. Okay. And this one is FP3H. This is the 2H. Okay, and the last one, this is the 1H, is 400. This is 1. Okay. Now we have all the planes and sketches that we need in order to build the plate and add the component. So we will start building the cavity plate. And first we activate the assembly, and then we add new components, and part name is um, F, sorry, is FP1. Okay, and this we use place on face options, and we select the um, this 1H FP1H, and then we place a point at the origin of the sketch. And after that, right click, select OK. And now we right click, select Sketcher, middle mouse button, and then we create a sketch. We select the edge geometry and we select um, this sketcher, and after that right click, middle mouse button first, right click and see sketcher, and then go to solid, new extrude. So this we use by reference, and we show the select this one, and then OK. Okay, and after that we will create for the clamping plate. So we activate the assembly. Okay, and add new component. This name is FCP, big side clamping plate, and save, place on face options. And we select this plate, and then we place the point at the origin here. Okay, right click. Oh, sorry, before that, yeah, right click, select OK. After that, we right click, select Sketcher, and we add geometry. We select this for the clamping plate, and then middle mouse button, right click and see Sketcher. Okay, after that, go to solid, new extrude. By reference, until here. Okay, and then right click, select OK. So please remember that do not use the face of the cavity plate as reference, so that we do not create the reference between these two parts that may later result in cyclic dependencies. So now we change the color. Uh, this we change, okay, and this we change to green. Okay, and this one we change to yellow. Okay. In step 8, we will bring in the components. So we start with the leading pins. So first we need to activate the assembly, and then we go to here, select more parts. This is add more components and select add more parts. And okay, at the catalog here we can select from the catalog. For now I'm using the Misumi, and so more components and select the leader pins. Okay, and the items we select the GPP leader pins. Okay, and D is 80 and this is 335. N is 100 and P is 75. And right click, okay, and we use place on face options and we select the uh, this these are F space plane, and again we cannot don't select the face of the cavity plate, and then we use add geometry, and after that we select the lead pin. Okay, and then so we go to the offset and rotations optional stage here, and we set the delta Z is 100. Okay, and then right click select OK. So this is the result, and then we activate the assembly. We add the component again, and this time we select the screw bolt, and category is cap screw, and this we use CB socket head cap screw, and the M is 24 and the length is 120. So we place on face options, and this time we select this plane, select this. Okay, and after that we select add geometry. We select the point here. Okay. Okay, and then right click with the mouse button, right click, select OK. So at here we right click, select hide other, and we activate it, and after that we double click, So we edit the length. This is the diameter, and we edit the length. So we open the setup table, and then we select the FCPH plus FP3H plus FP2H, and then plus the diameter times 1.5, and then click OK. Okay, and after that we hide the fixed setup part and activate the main assembly. After that we add new component. We add the assembly. Okay, and the name is F insert. And then we use on assembly UCS. Okay, and after that we can save and close. So this is the fixed site. In step 9 we will build the movable site sub-assembly. So same as the fixed site, we need to open a new folder under MoSet folder. So the folder name is movable site 6 plates. Okay, and after that we create a new assembly, and then we save it under the movable folder, movable site folder, and the name is movable site, same as the folder name, 6 plates. Okay, after we done this, we need to hide the PMI guide if yours also display, and go to views, hence guide, select the accelerate mode guide, and after that we select the setup tools, and this we change to mode design. Okay, and after that we need to load the type A template, so we check this, enable advanced editing options, and after that click OK. Now we can load the template, select it from the catalog under MoSet. After that click OK. After we done this, now we use add new component. Okay, new part, and this I name it as movable setup. Okay, and after that we select the on assembly UCS, right click, select OK. Now we need to create the movable side plate 1, the length and the width, same as the fixed side. So we will just repeat the step. So we need to select the schedule, middle mouse button to select the XY plate, and after that we create the rectangle. Oh, sorry, before that this, and this we change to from free to dimension, and the width we change to 100. And after that we place it at the origin of the UCS sketch, and then we right click Exit Sketcher, and then we rename this feature, name it as movable plate 1 length and width. Okay, and then we double click it. So same as the fixed site, we select the setup, and we select the width, and this is the length. After that, middle mouse button. Okay, and now we need to create the movable clamping plate. So we create another sketch, and we select a rectangle, free. Okay, and then we add reference with the mouse button, and we add constraints. This is same X. Okay, and after that we give dimensions. From here to here is about 180, and then this also 180. So this the rectangle is become purple, so that means it is fully defined. Right, after that right click Exit Sketcher, and this we rename it as MCP length and the width. So this is movable side clamping plate, length and the width. Okay, after that we double click the sketch, select the setup tables, and we select this delta. Okay, connect it to delta. Okay. Okay, now we will create the rails. So we start with the vertical rails, and right click and then select the sketcher, middle mouse button, and we add reference. We add it here and here, middle mouse button, we create the rectangle. Okay, and then we give dimensions. This is about 150, and this also 150. And then we exit Sketcher, and this we rename it as rails. Okay, double click, and we connect it to the V-rail width. Okay, and after that we go to the horizontal rails. So right click is Sketcher, middle mouse button, and we add reference at these two line. Okay, middle mouse button, and after that we create a symmetry line. and we draw a rectangle like this. Okay, here also same. And then we add constraint here, same y, and after that we give dimensions. This is 200 and this one is 500. Okay, and after that exit schedule. And the name is horizontal rails. Okay, and then so we double click here, and this we connect it to the horizontal wheel width. Okay, and this also same, and this is the length. Okay. After we done this, now we will create the leading pin sketch. So same as the fixed side. Right click schedule, the mouse button, and we add reference. Add this line and also this line. And then we draw a rectangle, something like this. Okay, and then we select 4 of them and change it to construction lines. And we create a circle. And the diameter is 60. Okay, and then we give dimensions. This is 150. This is 74. Okay, we add constraints, same x, and this is same y. After that, exit sketcher. And this name is leading pins. And we need to connect it. Okay, and this. Next, we will define the position of the screw holding with the main plates together. So we need to activate the movable side. After that, right click, select schedule, middle mouse button to select default XY plane. And after that, we select the symmetry. And this is new in Cimatron E10. We can select one axis or two axis. And at here we can select by point or by two lines options. So by point option is like this. So for example, I click on the UCS here. So this is the result for the by point options. Of course, now I don't want to use this. I want use is by 2 lines. So maybe I create from here to here, and then to here. Okay, and this we change to circle, and the diameter is 24. After that, we select the line, draw from here, and then continue until here. Okay, after that, we select the line, then we change construction line. Okay, after that we add geometry. We add at the middle point here and also here. Middle mouse button, and then we need to add constraints. So we select the circle and the at reference point. So this we select sim Y. This sim X. After that we give dimensions. This is 100. And from here to here is 120. And then the distance here is 275. So this is the result. Right click Exit Sketcher, and we rename it as M24 screws. After we finish for the M24 screws, now we will create for the vertical rail screw. So we also need select the sketcher, middle mouse button, and after that select the symmetry, use 2 axes by 2 lines. Okay, and after that we place the circle somewhere here, and after that the diameter is 24. After that we add reference, and then add constraints. This is same Y, and then we give dimension, and this is 100. After that, acid sketcher. And this name is vertical rails screw. Okay, and after that we need to define the screw for the horizontal rails. So select the sketcher, middle mouse button, and then also need to create the symmetry line. Okay, the diameter also 24, and we place it here. Okay, and after that we add reference, middle mouse button, add constraints, same X, dimension, this is 50, acid sketcher, and this name is horizontal rails screws. And the last sketch is for the dowel pins. So we select sketcher, middle mouse button, and draw the symmetry line. So this time the diameter is 16. We place it somewhere here, and then we add reference, and at the center here, add constraints, same same X, and then dimension, this is 70. Acid sketcher, this is okay. In step 13 we will create planes. That will be the base for the height of the plates. So we switch to set tabs, and then we show the archive, and then we go to datum, plane parallel, and this is one. Select apply, and then we hide the archive. Okay, and then we move pointing it in Z negative, and this is 300. Apply, and then this is 40. Apply, and 40 again, and this is 50. Apply, and this is 80. Okay, so this is M space, This is MP1H, MP2H, MP3H, and this is the rails height. This is the clamping plate height. So we connect it. This is M space. Okay. This is MP1H. This is MP2H. This is MP3H. This is the and the last one is the clamping plate. Okay, now we will start building the core plate. So we activate the assembly, and then we add a new component, new part, and this part is MP1. We use place on face option. And we select this plane. This is MP1H. And after that, place a point at the origin of the UCS, and after that right click, select OK. Next we select the schedule, middle mouse button, and we select add geometry. We select this, middle mouse button, and then exit schedule. And after that, we use solid new extrude. We use by reference, and by reference until this plane. And then click OK. Next, we will create the rails. So we need to add the new component. And this is rails. Place on face options, and then we select this plane. Right click, select OK. After that, select Schedule, middle mouse button, add geometry. So we select this, and then middle mouse button, delete it, exit Schedule. And this we use new extrude. Extrude it until this, the MP3H plane. Okay. So we will repeat it for the right side and also the horizontal rails. So now I will repeat it for the vertical rail for the right side. Okay, and then Schedule, add geometry, delete, exit Schedule, new extrude until the plane. Okay. So now we will do for the horizontal rails. So I will delete this, exit Schedule, new extrude, and until this plane. Okay. And for the last one is the horizontal rails right side. And geometry. Exit Schedule, new extrude until this plane. Okay. So this is the result. And after that, we will do for the clamping plate. So what we need to do is activate the main assembly, the assembly, and then new component, and this is movable side clamping plate. Place on face, and we select this plane, Okay, right click Sketcher, middle mouse button, add geometry, and we select this. RC Sketcher, new extrude until this plane. Okay, so this plate very thin, so we open the setup table and we change the clamping plate. This change to 80. Okay, and then we need to change color. Activate the main assembly. This we change it to this color, and this we change it to purple. And this one change it to green. In step 15, we will bring in the components. So we will place the screw first. We activate the assembly and that add component. We add screw. So we use the Misumi catalog, and after that select this screw bolt, cap screw. We use CV, and this is M24. And this is 380. Okay. We use place on face option. And we select this plane. Okay, and after that we add geometry. We select the screw. So we flip it. And then okay. And after that we will repeat it for the vertical rail screw and the horizontal rail screw. So this is 24, and this is 130. Okay. So we select this plane and we add geometry. So we will select the vertical screw. Apply. And we will repeat this for the horizontal rail screw. So this is the result. And next we will place the dovell pins. So we use small component and we select the dovell pins and we use this MSV and D is 16, so use non-standard, and the length is 120. Okay, so we place on face. We also select the clamping plate plane and add geometry. Okay, after that we select this, change the UCS of the other part, and we select this. And then click OK. Finally, we will add the leader pin bushing. So we use the more design and more components, more parts, and we will select the leader pin bushing, and we use this GBAM leader bushing head type, and the diameter is 60 and the length is 150. Okay, so we use place on face options, and then we select the M space plane and we add geometry. And then right click, select OK. So we hide the setup. And if you normally have insert in the in the movable side, it is recommend to add a sub-assembly for them at this stage. So we add new component, and this video assembly, and we name it as movable side insert. And this we use on assembly UCS. Okay. Okay, after we done the movable side sub-assembly, now we will build the ejection sub-assembly. So same as the fixed side and movable side, so we need to create a folder under the mold set. So this is ejections, 2 plates. Okay, after that we create a new assembly. and we save it under the ejections, and this also the name also same as the folder name, ejections to plates. Okay, and after that we need to select the setup. So this is mounting design. Okay, and we check this enable advanced editing options, and we load the template, type A template, no set. Okay, and after that we add new component, and this is ejection setup, and this by on assembly UCS. Okay, and right click, select OK. After we done this, we will create a sketch. So right click, select schedule, middle mouse button, and we draw a rectangle to size something like this, and we add constraints. This is same X, and this is same Y. Okay, and after that we can give dimensions, and this is 1000, and this is 500. And okay, after that we can access schedule, and this we name it as ejection plate length and also the width. So we need to edit the length. Double click here, and we edit this, and this we select the length, this M length, and after that we click type minus 2 times H rails, the horizontal rails width. Okay, and after that minus 80, and then click OK. So this also same for the 500, and we select and width, and then minus 370. After that click OK, middle mouse button to exit. Next, we will define the position of the screw. So we right click, select the schedule and middle mouse button, and we add reference. We add this and these two lines, middle mouse button again, and we draw a symmetry from here to here. Okay, and this we change to from free options we change to dimension option, and this we use diameter options, and this the diameter is 6, and then we place it here, here, and also here, and then middle mouse button. After that we need to give dimensions. So from here to here this is 50, and this also 50, 35. And then between these two the length is 300. Okay, after that acid sketcher. So we rename it as screws. Okay, and then we go to set tabs, and we on the archive. Okay, after that we go to datum plane parallel, and we select this plane. So you must make sure the arrow is pointing downwards. It means Z negative. So the delta is 500. After that, click OK. So we hide the archive, off the archive. So that means we off the XY plane. And we go to the feature tree here. And we need to rename it. And this is ejection start. Okay, after that we create another parallel plane. So we select this, and this time make sure the arrow is pointing upward. This is Z positive, and this is 50. Right click OK, and the name is ejection plate 2H. Okay, and we repeat it, and this is 40. And the name this one is EP1H. Okay, and then we double click the ejection start, and we go to the setup tables here, and we set the dimensions. We select the M space, and then plus 1H plus 2H plus MP3H plus the rails H, and then minus 5. Okay, middle mouse button, and we open the setup tools, and then we check this, and we need to change the value of ejection plate 2. So you can see the value is 0. So now I change it to 35. Okay. So this is ejection plate 2. Okay, and this okay. So this is the result for the ejection plane. Next we will build the plate. So we activate the assembly and then we add new component, and this name is eject uh, the, the plate, and then we use place on face options, and we select the EP2H, and after that we place it at the origin of the sketch UCS, and then right click select OK. So we now need to create a sketch. Middle mouse button, and, and after that we select add geometry. Okay, and then right middle mouse button, right click and set schedule. And after that we select new, right click select new extrude, and by reference, so select this EP1H as the reference plane, and then right click select OK. So we need to add another part. So we activate the assembly, and then we add new part, name it as eject the retainer, and this use place on face options, and we place it on the ejection start. Okay, and place point at the UCS sketch UCS, and then right click select OK. And after that we create sketcher, middle mouse button, add geometry, select this sketch, middle mouse button, and then right click and set sketcher, and after that right click select new extrude. By reference, we select this EP2H plane as the reference plane, right click select OK. So now we activate the assembly. We need to bring the screw, yeah, add component, um, screw bolt, cap screw, and this is M6 and this is 50. Okay, and we use place on face options, and we select the ejection start plane, and then we use a geometry. We select the sketch, so we flip it, and then right click select OK. After that we need to change color, select this, we change to purple color, and this we change to yellow. Okay, and after that, hide the setup. And if you normally use lifter, it is recommended to add a sub-assembly for them at this stage. So add new component and select assembly, and the assembly name is lifters. Save, and this on assembly UCS. Next, we will extract the mold sub-assembly. So we open the Cimatron E Explorer. So at here, we select the mold set under the catalog, Cimatron catalog. And after that, we select the ejection and right click here, ejection to plates.elt file assemblies, and we select cut and then paste it here. So we will repeat for the fixed side and also the movable side. So when we are do this within in the Cimatron E Explorer, and this way the link of the parts will be kept. Okay, and after that we click the fixed side sub assemblies. So we select the fixed side sub assembly, and then we select the at once, we click the arrow here, and after that we go to more as a type. Okay, and this we select the fixed SA. So this name is fixed sub assembly, and we change the category, change it to mode set, and the subcategories we change it to fixed site. And then after we finish all this, we click this submit subject changes button. So we will repeat this operation for the movable and the ejection sub assembly. So category will be the mold set, and subcategory this is ejection system. And this is ejection sub-assembly. Submit changes. So this also same for the movable side. Okay, this is step 20. Next, we will create the layout part. So we open the new assembly, and after that we save it under the MOSET folder. Okay, and the name is not important, and because we will delete it later on. And after that we create new part and name it as layout type A. And after that we use on assembly use CS. Okay, now we open the mode guide and we select the setup and select mode design. So same as previous, we need to load the template. Okay, after that we need to repeat the creations like the movable side, movable plate, length width, movable side, clamping plate, length width, sketch, V-rails, H-rail and leading pin. So we will repeat all these. Okay, now we select the rectangle, this change to dimension and this is 100. Place it here. Okay, and then exit sketcher, and the name here change it to P1 dash L dash W. Okay, and after that we need to connect it. So this is M width. Okay, this is M length, and after that we create another sketch and this change to 3, something like this, and after that we add reference and we add constraints, same Y and this is same X. Okay, and after that we give dimensions. This is 180 and this also 180, and then exit schedule, and the name is CPLW, and then we connect it to the delta clamping back delta. Okay, and after that we need to create the vertical rails. So we need to create a sketch and we add reference, we add these two lines with the mouse button, and we create the rectangle, and then we select the dimension and this is 150, this also same,
After that, exit sketcher. This is vertical rails, and connect it to the rail width. Okay, and this also same. And then we need to create the horizontal rails, and we need to add reference and select the symmetry line. After that, we draw a rectangle. Okay, we repeat it for the other side. And after that, we add constraints. Same Y. And then we give dimensions. This is 500. And this is 200. This also 200. And then we exit sketcher. This is horizontal rails, and this one we connect to the width, and this is the length. Okay, after that we need to create the leading pin sketch, and we need to add reference. We add that here and here. After that we draw a rectangle like this, and then we add constraint. And after that we change this line to the construction line, and then now we need to create a circle. So the diameter is 60, and then we give dimensions 74 and 150. 150 before, and this is 150. After that, exit schedule. This is leading pin. Okay, and this one. Okay, this one is okay. Okay, after save the file, and then we open this. Okay, and then we create a sketch. We add the point at here. Sorry, is just select the point, single point, and okay. After that, go to datums and select UCS, layout UCS, and select the point, middle mouse button, and after that right click, select OK. So this is the layout. So now you can save the file and close it. And after that we need to delete this. Right click, select delete.